Okay, gang, we are going to take some time to discuss greatest common factors and greatest common factors. And I should say at the end of this little video here, you need to be able to, I guess, find the greatest common factor of two or more whole numbers. So first of all, quick review, just from our previous section, prime numbers are numbers greater than 1 that have exactly two factors, one in itself. And then composite numbers are whole numbers that have more than two factors. Okay. Now a greatest common factor, and up here at the top in bold-faced, here is sort of the textbook definition of greatest common factors. And then here, the largest number that will divide evenly into others. Okay, so for example, the greatest GCF, the greatest common factor of 27 and 45 will be 9. And we're going to figure out how can we find this value of 9. And it happens to be 9 because 9 is the largest number that divides evenly into both 27 and 45 without remainders. Okay? And so we will talk about how to do so. And so I have two methods for you. One is the list method. Now the list method is generally not my favorite kind of method. It works okay for relatively small numbers, all right, but it doesn't work all that fantastic for large numbers, okay? So here's how the list method of works, okay? So we're going to try to find the GCF of 24 and 36 and 48. So what is the biggest thing that divides evenly into all of those? And the list method is just that. Make a list of all of the numbers that go into each of these things. Now, I like to do it in terms of numbers that I can multiply together if I can. So I know that 1 times 24 is 24. Okay, so that one's easy enough. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. 5 would be the next one. It doesn't. So here are all of the factors of 24, the things that divide evenly into 24. You then do it again for 36. And so again, I know, and I like to do this table, sort of setting up a table. It just seems to work best for me. Well, you can just list them out if you wanted to. 1, 2, 3, 4, 6, 8, 12. And put them in a line if you want to. But this helps me to get all the factors, or at least to try to get all the factors, and hopefully not miss things. Okay, so 36 is 2 times, what, 18? And 3 goes into 36. That'd be, what, 12 times? 3 times 12 is 36. 4 times 9 is 36. 5 doesn't go in there. Oh, and then 6 times 6, so I can just list that once. We know that it's going to multiply by itself, and I think that gets everything there. Factors of 48. 1 times 48. And we know that, 2 times 24. And let's see, 3. 48 divides by 3, that's right. 3 times 16. And 48 divided by 4, that'd be 12. So 4 times 12. And 5 doesn't go in there, not evenly. 6 times 8 is 48. And then we would have 7, but 7 doesn't go in there. And I do like, if I'm going to list, I don't mind it for small numbers because these are relatively easy to come up with. But if you had greatest common factor of 584, well, that gets ugly. So now, once I have them all listed, what is the largest number that goes into all of them? And it looks like probably 12 is the thing. Probably 12, because 16 is not on all 3 lists, 24 is not on all 3 lists, 48 is not. Okay, so these bigger numbers. So it looks like 12 is the largest thing that goes into all 3. Now this method requires you having to know all the factors. And I prefer what I would call the prime factorization method. And so this is where you need to write the prime factorization. You will then identify prime factors from both lists and multiply common prime factors. I'm a rule kind of a guy, and so here are the steps, and you'll want to write these down. This is a lot less haphazard than having to come up with the list of factors and so on. So we're going to do the prime factorization of 60 and 45 first. Now, how you choose to do that is up to you. And so if you're a factor tree guy, well, in one case I'll do it by factor tree, in another case I'll do it by step diagram. So 60 is 6 times 10, because we need the list of prime factors. That's the first thing in the directions. And then 2 times 3, and 10 is 2 times 5. Okay, so here is my prime factorization of 60, and my prime factorization of 45. I'll go ahead, I can do this in green, it'll be alright. And I'm going to do the step method over here just to show that it can be done. 45 goes into 45 9 times. 9 is 3 times 3, and I now have my thing. So what I'm going to do, and I'm going to list this, and I'm going to try to put these in order, just because it usually helps if you put them in order. So the prime factorization of 60 is 2 times 2 times 3 times 5. And in this case, I do want it written out. And then 45, doesn't matter which one you put on the top or the bottom, is 3 times 3 times 5. Okay? I can't seem to write 5s very well. But what I'm going to do is I'm going to identify the items that fall on both lists. So you'll notice that 3 falls on both lists, and so does 5. So I'm going to pull those, a 3 and a 5 out. 3 times 5 is 15. So 15 is my greatest common factor. It is the largest thing that will divide into both 60 and 45. And I like this because it gives me specific steps of what to do. Okay? Where on the list method, especially if I have some really big numbers, it may take all day to come up with a list, where here I have a definite set of steps to follow. Okay? For example, and here you're going to see where trying to list out all of the factors of 504, 132, 96, and 60, which you'll notice here, I've already done the prime factorization, but you would have to do a factor tree and all that stuff if you did. But so I'm taking one of the steps out. I've already done, here are my prime factorizations for all of these numbers. But you really think about just making a list of all of the factors of 504. And then making a list of all of the factors of 132 and 96 and 60, and then trying to figure out what is the biggest thing on all those lists. That takes forever. At least using the greatest common factors and the prime factorizations, I have a definite method. So here are the prime factorizations for these numbers. So I am going to now, once I have them all listed and done, I am going to identify the numbers that fall on all of the lists. And in this case, instead of a circle, I'm going to just draw a line. So I've got a 2, and that's my little arrowhead. Sometimes I'll draw lines. And a 2, although my lines are not very straight. 2 falls on every list. It looks like a 3, and either you can pick any 3 you want. 3 falls on each list. And I have 5 here, but 5 doesn't. So I've got 2 times 2 times 3. The solution to that, 3 times 2 is 6, times 2 is 12. 12 will be the greatest common factor. So in this case, we're looking for the factors that fall on every list. And so once I have the prime factorization, use a factor tree, use a step diagram. Doesn't matter, but once you have them listed, you just simply identify all of the factors, and you pull those factors out that are common on each list, and multiply them together. So, and we can apply this to applications as well. David is making favor bags for his birthday party. He has 50 confetti eggs, 30 noisemakers. What is the greatest number of matching favor bags he can make using all of the confetti eggs and noisemakers? So he's going to make up bags as sort of gifts or whatever for his party. and he needs to figure out, well, how many bags can I make if I have 50 eggs and 30 noisemakers, and I'm going to put them in the bags evenly, okay? So this means, first of all, let's go ahead and do our greatest common factor. I don't care, again, how you choose to do it. Here's 5 times 10. I'm doing factor tree first. 2 times 5. So, okay, there's my prime numbers here. Okay, so there's my prime factorization will be 2 times 5 times 5. I'll bring that down in a second. 30, you know, 30 just to show that I can do a step diagram. 30 is 2 times 15. 15 is 3 times 5. So my prime factorization of 50, and I'm going to list it here, is, and I'm going to put it in order. Usually if you put them in order, it makes just the lining up of things easier. So 2 times 5 times 5. You don't have to, but it does tend to make things a little more organized. 2 times 3 times 5. And I will now, let me change colors here in this case. I'm going to identify the things, small list, so I'll go ahead and use my circles again. 2 and 5 are the things that show up on both lists. So I've got a 2 that I'm going to pull out. I'm going to pull out a 5. 2 times 5 is 10. So 10 is the number of bags that I can make with these equally distributed noisemakers and confetti eggs. So, all right, so your turn to go ahead and get some work practicing with our greatest common factor. Good luck.